Hello everyone. Welcome to the lecture series on IC engines. I am Dr. Anuranjan Sharda, professor at GNA University Fagwada. We'll be continuing with our lectures on parameters affecting the performance of IC engines. Today we'll be talking of how to measure these parameters. So by the end of this module, learner will be able to measure engine parameters such as torque, speed, power, fuel consumption, exhaust temperature, and other performance indicators. He will also be able to construct and analyze heat balance sheet through the development of ability to tabulate energy input and energy output, identify losses, and suggest the improvements. This is the index of our lecture series. We'll be talking of measurement of brake power, measurement of indicated power, including methods such as motoring test, Willen lines method, engine indicator, and MOS test. In addition, we'll be talking of measurement of rate of fuel consumption, measurement of rate of air consumption, the heat and the heat balance sheet. Let us talk of measurement of brake power. As we have already done, we have measured the brake power using the brake dynamometer. You can see here the forces are applied, the brakes are applied on this pulley, and when it stops, it reduces, this RPM reduces, and by measuring this RPM and the torque, we can calculate the brake power using the formula 2 pi nt by 60. Similarly here we are using hydraulic dynamometer. In hydraulic dynamometer, water is sent into these grooves. In this we have the red color rotor which rotates along with this shaft, and the blue colored stator. In between these two, rotor and the stator, there are grooves. In this groove the water flows inside. Now as the shaft rotates, it tends to rotate this water circulation, and hence the stationary casing experience a torque. That torque is measured by a gauge, and speed you can calculate by the help of tachometer. So hence again using the same formula for brake power which we have already talked of, brake power is equal to 2 pi nt by 60. So that using n from tachometer and t from the gauge, you can calculate the brake power. Similarly in the third one, we have this rotor. Red color rotor is there, around which the stator is present. Stator is experienced the DC sources, current is passed through it. So due to that current, constant change in flux density at all points in the stator, it results in the formation of eddy currents. So these eddy currents opposes the motion of the rotor, and thus this resistance is measured by the help of this torque arm, and then we can calculate the brake power by measuring this torque and RPM. So same methods are used for all three cases. Now here we are using the mechanical brakes. In the hydraulic dynamometer we are using water as a breaker, and in this eddy current dynamometer we are using the formation of eddy currents in the stator as a resistance to the motion of the rotor. Now next, there is measurement of indicated power. As we already know, indicated power is the power produced inside the cylinder. So here we use different methods to measure indicated power. So first method is the motoring test. As the name suggests, the engine is made to run as a motor. So that means there will be no burning of the fuel here. So you can read the procedure. Engine is first run to measure the BP at a given speed. fuel supply or the spark is cut off. So you are not providing any spark. And the dynamometer is converted to run as a motor to drive the engine. So hence the name motoring. So engine is run again at the same speed at which the brake power was measured. All other parameters are kept same. Now power supplied to the motor is measured, which is a measure of the frictional power. So from this frictional power and the brake power, we can calculate the indicated power as the sum of BP and FP. Now there are some objections to this method because the engine is not firing, which leads to running conditions. They are not similar to what they will be when the engine is running, because the higher temperature are encountered during combustion. The pressure and temperature of the cylinder contents, cylinder and piston surfaces are not the same. The other method for measuring this indicated power is the Willen lines method. This is used only for CI engines. So in this method, fuel consumption versus brake power graph is plotted. On the x-axis we take brake power and on the y-axis we take fuel consumption. And you change the speed and measure the brake power. So at constant speed, the brake power and fuel consumption consumed is plotted, and you get a curve. You extrapolate this curve up to the x-axis. So when we extrapolate it, this curve cuts the y-axis at B and x-axis at A. Now when we talk of OB is representing fuel consumption with zero brake power. That means we are not generating the power, but the fuel is still consumed. Whereas OA is representing the power which is consumed at the zero brake power, and hence it represents the frictional power. So you can calculate both OA and OB. Now OA represents frictional power, brake power you can measure with the help of dynamometer, and hence indicated power can be calculated. The other method for measuring indicated power is the engine indicator. So to determine indicated power, PV diagram is required. Since PV diagram, the area enclosed in the PV diagram, it gives you the work done. So hence the power can be measured. So the area of which represents work developed by the engine per cycle. Now apparatus used for drawing actual PV diagram is called the mechanical or engine indicator. So this figure is shown here. So engine indicator consists of the cylinder. You can see this cylinder, the piston rod, then the coupling net, the straight line linkage with stylus. You can see this straight line linkage. Then spring of required stiffness. So here the spring is provided. Indicator card, wrapped drum. Now this is the indicator paper which is wrapped on a drum. Now what is there? As the engine moves up and down, the motion, this vertical motion, it makes this stylus go upward, and because the distance covered by this piston is representing the volume, so the volume line is covered on this side. So by the rotation of this cylinder. Now rotation takes place due to the movement of this string. So this string moves over the pulley rotates. Now this string is attached to the weight which pulls it. So area of the indicator diagram can be measured by planimeter to a definite scale giving work developed. Planimeter is a device used even by patoaris of land revenue records. So they run the planimeter over the lines which are drawn, and hence when they come to the initial point, the planimeter gives us the area of that enclosed figure. So IMAP is the average pressure which, if acted over the entire stroke length, would produce the same work done by the piston as is actually produced by the engine during the cycle. So now you can see this diagram. So let A be the net area of the diagram. So you can have IMEP is equal to work done upon swept volume. So you know the area enclosed by this diagram, this gives you the work done A, and the length from here to here, this gives you the swept volume. So A by L, it gives you the indicated mean pressure. Now what is this K? K is the spring constant that we are using. So depending upon the spring, this pressure will change. So hence A by L into K will give you the indicated mean effective pressure. By using this PM, you can calculate the indicated power as PM LA NK by 60, where L is the length of the stroke, A is the area of the piston, N is the number of strokes, number of working strokes, K is the number of cylinders. Now the other method which is used to measure the indicated power include Morse test. Morse test is applicable only to the multi-cylinder engines. It cannot be used in single cylinder engines. It can only be applied to the multi-cylinder SI engines. So here what is there? The engine is run at a required speed and the torque is measured. So by using that torque, we measure the brake power again by using the formula 2 pi nt by 60. Now secondly, one cylinder is cut out. Say number one cylinder is cut out. Cut out means we are not providing the spark to the engine. The speed will fall because the power has been lost, but it is restored by reducing the load. So how the load is reduced? If we are having a brake dynamometer, we decrease the amount of load which we are applying. The torque is measured again when the speed has reached its original value. So again the torque is measured. So this power, by this torque, the power which will be measuring, that will be called BP1 cutout. So that gives you the brake power with first cylinder as switched off. So in the similar manner, we calculate BP2 cutout, BP3 cutout and BP4 cutout for a 4-cylinder engine. Now, if the IP of the 4-cylinder engines are denoted by IP1, IP2, IP3, IP4, so BP will be given as the difference between all the IPs and all the FPs. So indicated power minus the friction power. So now if we are cutting one cutout, IP1 will not be produced. So deleting this IP1, you will be having the indicated power produced by all 3 cylinders like IP2, IP3 and IP4. But the frictional power of all 4 cylinders will be included. Why it will be included? Because though the power is not being produced, the movement of the piston of the first cylinder will still be there because it is also connected to the same crankshaft. So hence you are having FP1, FP2, FP3, FP4. Similarly for BP2 cutout, IP2 will not be there, but all 4 FPs will be there.
Thank you.